Hello everyone and welcome to my new tutorial. Um, this scene was inspired by a great short movie made in Blender. It's called An Ode to Racing a Lamborghini. It's quite cool. I wanted to show you a shot. Here we are. We can see all those lines. Those ones. So I love this shot and I wanted to replicate the lines going over the car and make something procedural. So a setup that is not bound to the geometry but can be used with almost any geometry. Um, let's see what I've done here. A little note, you can see that I'm starting my timeline on frame 1000. This is a new habit of me. I learned this while working on visual effects for Refuge FX Studio, the best studio out there. This is because if we need to do pre-roll for anything, for a Phoenix simulation or for a TyFlow simulation, it's easy to just start before, like 900, and at the frame 101, you have the particles or the simulation where you want them instead of of having the timeline starting from zero and have negative frames. This is my new habit. So let's see what we have here. I have a very chunky car model. This is just a proxy, and you can make this for every model. You can like make a proxy version for the simulation. And then I have this flow. As you can see, I'm birthing my particles on frame 950, and I'm saving the birth ID for each particle because if I want to make some changes on the flow, this might turn useful. But let's just ignore this for now. And I am spawning them every frame, and I am placing them on an icon every frame. And this is the icon, giving them a scale and giving them a speed along this icon. Let's hide the spline and see the particles. And how am I like making them follow the surface? This is basically done with the push. It it the particles gets pushed off continuously from the surface, and then I add some surface force to do. We can see here on the left. I'm like when the particles are close to the surface, I'm pulling them a bit. Only if they are in a very close radius. Um, 1 centimeter plus 1 centimeter fall off, and also I'm using some follow force that use the surface um, to give force to the particles. This is not necessary, but I like the result. But if I turn it off, it will still work slightly different, but still work. But I like how it behaved, so that's what I'm doing. I'm keeping it on, and then my problem here was that I want the particles to get back to do that, in a wind tunnel, of course. When they leave the body that they're hitting, they get back to go sort of straight. If we see some videos about it, let's see if I can find some. Okay, so here you can see that the flow gets back to like it straightens up after the car. It doesn't follow, it doesn't go to the ground, and that's what I wanted to have, even if it's a stylized wind tunnel. But that's what the result that I wanted. Um, so if I turn off this operator, you can see the result that I wanted, that I want to avoid. Um, then we have a collision with the ground, and to make them like sort of bounce if they get to the ground. Um, Basically, that's it. This is a simple version because there is a way more advanced version, but this tutorial is going to be about the simple one. Okay, as usual, what I love to do is to redo everything. Um, let's start from scratch. Let's create a new flow, and let's birth 100 particles and spawn them by frame in a continuous way. Oops, this is a mistake that I tell my students to never make, and now I made it. You can see we had 11 million particles just in a bunch of frames because they were going in exponential mode. Like every frame was 100 spawned, then 200, then 400, then, well, exponential, you know what it means. Now I press Shift and S button to interrupt the simulation, and let's bring the spawned ones in a new event so I will not have this problem anymore. Um, I'm gonna use the same icon, no need to create a new one. Position icon, here it is, and there it is. And we can pick it and then have a speed based on the icon direction. Along icon arrow. Okay, here it is. Um, so I have particles that just do this. Now let's increase the speed quite a lot, like 15. Oops, 15, and let's make them with some variation. We could see um, the stepping problem without the variation. Like we see each step uh, of the spawning, but if we add variation, oops, that problem kind of goes away. And then maybe even 20. Okay, and then when they hit the card, nothing happens because I didn't tell them to do anything. But here's the time to add our push operator. and I set the timing to continuous because I want them to be pushed continuously. And I could pick the car, but I'm using a tie switcher because, as I said, um, I want this to be procedural, and so I'm using the helper, the TyFlow helper tie switcher. That is just, it does what it says. It switches from one geometry to another. So I'm gonna pick the tie switcher, and as you can see, it's already working. The particles are getting pushed away by the surface, and the reason, again, I'm saying this should be procedural. Uh, if I make, let's say, a good old torque knot, for example, and I pick it on my tie switcher, and I set my switch index to 2, and now, yeah, the particles are not are getting pushed by the torque knot geometry. This is a nice way to keep everything procedural instead of having to go inside each event where you pick the geometry and change it there. You can just change it with one click. So I don't need the torque knot for now. Back to the car. Let's make the splines. I'm gonna use the spline paths and the trajectories, which is the simplest method. It's gonna work for this to obtain this effect. I'm gonna create a new one, and let's see what happens. You can see that the splines keep on growing, but what I want here is to limit the age to 3 frames, and now you can see that I have those bits and they follow the car. Bit too much. I can go to the spawn, and I don't know, let's spawn 30% with a variation of 15. Yeah, now they're less. We could go even lower. Let's see what I've done in the other one. Oh, of course, I went per frame and I gave this value and a variation on the particle count. So let's do the same instead of per step, per frame, and 0.2 per frame, which means 1 every 5 frames. And then we can tell 100% with a high variation, 80% variation. Okay, so now I have some nice variation on the particles, and let's turn on the car model. Okay, so let's give them a different material ID. I already prepared a material here. There it is. It's just a multi-sub-object with 5 different materials, and so I'm gonna go in the materials tab and set this to frequency because I want the white one more than the others, and like 40, 15, 15. Yeah, that should work. So more of this and more 40% for the first one and 15, 15, 15, 15 for the others. Let's give this material, and there we are. Okay, so it's already working. It's quite simple. If it doesn't follow precisely, it might be a matter of time steps. Okay, let's see what is happening here. I turn it off because if I make changes, I don't want to re-evaluate every time. Oh, okay. Let's see if we can change some settings here. Let's go back to half a frame and let's set this to face, which should be the more precise. Yep. Okay, here we are. Nice. So they are already going straight because the surface push the particles only when the particles hit the surface, basically. The thing is, it's a bit too straight. We don't have any kind of interesting movement, and that's where I'd like to add a surface force, which is going to use the geometry to pull with some force the particles when they're close, really close. We might even give some more. Let's see what happens if we give them some more fall off. Okay, you can see that now it's doing what I would expect. I mean, here there is a hole and it's going inside, and maybe we can give some variation here. Let's see what, yeah, we get this instead of having like straight lasers, they're moving in a more interesting way, in my opinion. Again, yeah, that's way too much, and also we should give, okay, now it works. Maybe even less, and let's not give the force like all at once, but in 4 frames, in 4 steps actually. 25% is per step. Okay, this surface force gives the particles some nice movement, but now I introduced this problem here that I don't like. It's not very visible, but I'd really like them to go back to be straight. It's a stylized animation, and that's the style that I want to follow. So we can even see if some more, yeah, something like that. Okay. Um, yeah. How do I how do I straighten them up in a procedural way. I could give, well, first and first, let's see what happens with the speed operator. Let me show you this mode in the speed operator. Uh, it inherits the velocity, but it gives the direction of the icon again. So if I set this and I set this to continuous, I kind of reset everything, right? And I don't see anymore the surface force. So I want this to happen only after the particles leave the surface. How do I obtain this? Well, I could like add a collider here, but I want this to be procedural. So if the car is like a mini car instead of this one of any kind of geometry, I want this to be dependent on the surface topology, not on a collider that I have to move for the next geometry and whatnot. So what I can do is, let's turn off the flow, and I can just make a surface test. And again, I'm gonna pick my tie switcher, and instead of sending out, I can save all the test values of the distance from the surface in a custom float. If you see my previous tutorials, you know that what a custom float is. It's a tag that keeps a value on the particle. So I'm gonna call this my distance, and this saves the distance every time. When the distance is large enough, I want this to kick in, but there's a problem. This will kick in even before, so because here is very distant, and maybe if I want to add some like other force here in front changing my flow, this will be a mistake. I want this to happen only afterwards. So what I can do is like save this just from, I don't know, an H test of 50, because they take a few frames to reach the car, right? Okay, let's say 25, 30. Okay, any value after 30, I know that the particles are already going on top of the surface, and so what I can say here is that activate this only if um, if the distance, which is a custom float, if my distance is less than, I don't know, is greater than, um, I'm gonna try some value here, 30 centimeters with a variation of 50%, then kick in. If not, this is not gonna be activated and the particles will be free to change the direction. What this does, it resets the direction based on the icon arrow. Let's see what happens. And now you can see that they follow the car, but here they get back to that direction. And I can change this value if I want them to, I don't know, like this. And now I have the effect that I wanted. I can even give some interpolation, so this doesn't happen too sharply. Here we can see it happens. I can set this to 0.25, And so this happens very smoothly. If you see my previous tutorial, you know what a interpolation does. It basically activates force in this case, even if it's just changing the direction, still a force. It, instead of happening immediately, it applies it on a range of frames. In this case, using normal interpolation, and 0.25 is gonna take 4 frames, if I remember correctly. But this is literally something you can play with. And then we can, if we don't want infinite particles, we can delete the particles continuously. Again, with the same filter, we can copy the filter and append it and give it a way bigger distance, like, I don't know, 300, for example. Okay, one last thing that we can do instead of making them appear. This is a completely stylistical choice, but let's say that we want them to appear gradually and get away gradually. So we can see that the TySplines object in the TyMesher has a setting that multiplies by the particle radius. So if, for example, here we have the scale operator, okay, and let's say that I make this 500. You can see that now these neon particles are way bigger. We can use this to our advantage because the scale operator has a proximity mode. Let's see what it does. Sorry, small crash. So I did something that 3S Max didn't like. Back here, instead of using this scale method, let's set it to absolute and the timing to continuous. So every frame is gonna reset the scale, the absolute. That's what the absolute value does. But instead of leaving it like this and having this going full scale from here to when I delete them, let's just use them multiplied by proximity, and the proximity, of course, is our tie switcher here. And now we can see that they scale up and scale down. This is done because I set the spline, the tie spline, to multiply by not radius. And what I can do here is change the fall off and keep this. This is the minimum distance where they're gonna be like full scale, and I can keep this close to the car. And I don't know if you like them this big, but I'd say something more like this, like the reference. And that should be it. I made a very simple camera animation, and this is the simple version of the tutorial. There's a more advanced version with a lot of use also of the very new uh, amazing values method, uh, where you can drive things using these values. But that's well, for the next tutorial. And here's the news that I Well, it's not a secret if you follow the TyFlow Facebook group. Um, I wanted to do a TyFlow course since a lot, but there's been a lot of obstacles. Like I had some health issues, some life issues, and in my what I prepared is a massive uh, course. There's like 14 scenes, and each one takes hours to explain and eviscerate every decision and everything that we can do. And I wanted to do it like that because I do believe that doing all these lessons will take you to the next step, um, and will make you ready for basically almost everything they can throw at you as request for either motion graphics or visual effects, uh, or at the very least give you a very solid base. um, the thing is, if I wanted to do it as a whole, it's too big and I would have to focus on it for months and like give up everything else, and I cannot do it. And also there's been unseen obstacles, and so this wasn't, I don't think I would be able to do it, but I didn't want to throw away all the material. Also, being this big, but TyFlow changes so quickly that a lot of lessons could become obsolete. Some of them already are, and I have to update them, for example with this value operator. um, and so here's the big announcement: I have a pattern where there's gonna be uh, free tutorials. I'm gonna keep on posting the free tutorials also on the YouTube channel. Um, then there's gonna be two tires, a mid one and an advanced one. The advanced one is the one where you find the TyFlow Mastery course, and I'm gonna update it constantly until all the lessons will be up there. And I'm way more I'm convinced that that's the right way, because this way I can quickly I don't know, add a new small video if something new comes out, um, or if the followers, if there will be any, will ask me something about the lessons. It's going to be more interactive than a whole course that you can just buy on, I don't know, Udemy or stuff like that. And just to give you an idea, this tutorial is going to be free, and the advanced tutorial is going to be in the mid tier, and the only the very advanced ones are going to be in the advanced tier. So that's it. I hope you enjoyed this one, and I hope you like the news. Don't worry, there's gonna be, as I said, there's gonna be free tutorials. If you wanted to just see the more advanced versions, please consider picking a mid or advanced tier. Thank you.